Hi class, in this video we're going to talk about using functions in MATLAB. So up until this point we've used scripts to execute multiple lines of codes. However, functions allow us to have a method where we can provide answers based on a user supplied input. So functions have both input and output. There are three types of main functions within MATLAB. The first type you've already been using, actually some built-in functions such as ones, zeros, you may have used mean or abs, log. So these are built-in functions that MATLAB uses based on some input that you pass those functions. Another type is an anonymous one-line function that can be defined in the command line and they are saved as variables of class anonymous function. And finally, one of the most useful ones that you'll use over and over again to make your own function are custom multi-line functions. These are saved as M files. These are different than script M files for MATLAB. So note, whenever possible, MATLAB has a lot of built-in functions, so use these. So don't go ahead and reinvent the wheel because MATLAB has spent a lot of time getting the functions very efficient for you. So don't build a function for making zeros. It's better to just use MATLAB's functions. And you'll find that if you're doing something often over and over again, there's probably already a built-in function with MATLAB, so you don't have to actually write a custom function. So what is the difference between a script and a function? As we stated before, functions are specified sequence of codes that take an input and return an output based on the user input, where scripts are lines of code that will contain all the data or variable to be executed, and when ran, they will just run without input from the user. So scripts do not take inputs when called. So one of the main differences between scripts and functions is how memory is stored and accessed for a script versus a function. In your workspace, there's the window that tells you the variables that currently exist in your memory. When executing a script can access any variable that's currently in your workspace. However, when you call a function, you may pass it variables in your current workspace, but once MATLAB begins to execute the function, it will pass those variables to the function. Once this occurs, there's a new workspace. This is a temporary workspace. The variables here will get temporarily created while a function is ran. So we're looking here at an editor window, and what you can see is that the workspace no longer has any variables. In fact, the only variables that it has are the ones that are passed to it from the user inputs. However, the variable x, mu x, and stdx do not exist within the workspace outside of this function. Now that we know how to structure functions, it's important to know how to call functions. Unlike scripts, functions must be called, where a script can be executed or ran. When calling a function, you must ask for the outputs that you actually want. If only one or no variable is asked for, the first output will be given. That is the first output that the coder wrote for the function. If you'd like to get multiple outputs, you must request them. And to do that, you can do an array or brackets and give variable names for the outputs that you would like. For example, if you do help max, you'll find that it returns the indices of the maximum values of a vector. So y and I, there are two possible outputs for the user to get. So if we were to make an array called x, but then you just typed in max x, you will not get y, which is the maximum value, and I. You only get y, so you only get the maximum values. That's because this is the first value. So by default, MATLAB just returned 3. And it also did not assign it to any variable because no variable was assigned to max, so it just gave it to a and s. However, if when you call max of x and you assign the output to max x and say another variable index, what you'll get is MATLAB will return the largest value in the array, which is 3, and assign it to our variable called max x. It will also assign the index of that variable to our variable called index. So if you see, note back up here in our array x, the largest variable was 3. So the index of that is 1, 2, 3, 4. So because we asked for that, we were given it and assigned to our variable index. So when you have your MATLAB editor open, you can go to New, and you can just open a generic script. And I'm going to split both these windows. So now I have my script editor on the left and my command window on the right. I like to do that because I can access my command window. I can look at the variables that are in my workspace, or I can be working on my script. Another thing that you can do is you can go New, and that would make a new M file, blank M file. And also under New, you can actually, if you're going to write a function, you can go ahead and click on the function, and it actually has a nice template for you with the correct header, a space holder for the outputs that you could or couldn't use, and then a title, untitled 8, which you're going to change. I usually just go ahead and start from a blank template, but you can go ahead and do that. So what I want to talk about right now is how we use the debugging. So for example, if I were to put in a function that I have on the slides, and this is the name of it is compute. It takes input capital X, Y, and gives out W and Z. So that would be the output of my function. And as soon as I make this function, I'm going to go ahead and save it. And MATLAB already knows to automatically save it with the same file name. So don't change this file name, because remember that it has to be exactly the same as the name of your function. Now if I come over here and look at my current folder, now I have a compute function. Okay. And what I could do is make a new variable. Let's say little x is equal to 1, and little y is equal to 6, just for argument's sake. And if I want to call my function and ask it to do the computation, so over here I have this function, but I want to execute this. It's different than a script. I can't just run a function, because it's not a script. You actually have to call it. So in order to call it, I'll type in the function here, compute, and then I'm going to give it inputs, and it's expecting 2 inputs. So if I just did compute, it's going to give an error because it's expecting me to give it 2 inputs, and I didn't give it any inputs. Whereas a script, I could just run a script, like I could run the script from our review today. So I could run that. I didn't give any inputs, and that will give you all of the outputs. Okay, but so that's sort of a different thing. Is you can run scripts, you can't run functions. So I need to call functions. And what I'm going to do is say compute little x. So I'm going to pass it little x, and I'm going to pass it little y. Now you don't actually have to give variables. I could just say compute 1, 2. That would be perfectly fine. Now what happens here is it's kind of a black box. We just got an answer out. And then let's go ahead and look over here on the left. Now there are supposed to be 2 outputs. There's supposed to be 2 outputs, but I only got 1, and it assigned it to A and S, the default variable, if you don't set it equal to anything. What I need to do here is I need to ask or request both outputs. So in order to do that, what I'm going to do, and actually it's kind of even good practice, is to just go ahead and copy from your function, put it in your command window to call it, and then I don't have big X and big Y, so I'm going to do little x, little y. And now this is going to assign the first output to W, and the second output to Z. Now I can name these anything I want. They don't have to be the same names here. So let's just do little w and little z. A note is if you don't request both outputs, it's by default going to give you just the first output. So in this case, it just gave us 7, which makes sense because we passed it 1 and 6, and what it did was compute w, which is y. Y was equal to 6, added 1, and gave us 7. Okay, so I execute this, and now I get both w and z. But what if I wanted to go ahead and see this function kind of execute as it goes? So what we can do is we can set a breakpoint, and we can set multiple breakpoints. So I'm going to go ahead and set another breakpoint. So now I have 2 breakpoints. First, you need to save it. And then when I go ahead and run this function, what it's going to do is, you see on my command window, it says paused in debugger. So it's not giving me an output yet. That's because I need to tell it to continue to run. And if you look over here to the right in my workspace, I used to have a bunch of variables. This is actually now showing me just the local variables to this function. So these are temporary variables. They're going to be deleted as soon as this function completes its execution. So I passed it 1 with little x, and it's actually already assigning that to big X. And I passed it 6 with little y, and it's passing that to big Y. So now it automatically creates those variables in the local workspace for the function. And this little arrow here is indicating that I'm about to execute this line of code. It has not yet. So the breakpoint will execute everything up into that. If I want to continue, it'll just run the rest of the code, or you can step line by line. Since I set 2 breakpoints, it's equivalent if I did continue or step. You can also step back or run to cursor, or you can just execute the rest of it or quit the execution with the quit debugging. So if I run this line of code, what I'm going to get is the local variable y plus 1. So that's going to give me 7, and you'll see that it'll store it in a temporary variable large W. So let's continue, and now it just created that in my workspace. Now this is not a workspace that I'll have access to once this function continues to run. Then it's going to go to the next line and create Z, and then I am immediately taken out of the function, and you see now I don't have large X, I don't have large Y, I don't have big Z or big W, capital I mean. So that's how the debugger works. It's very useful for go ahead and run your code line by line and figure out how your code is going to be executing. So I want to point out right now sort of one of the most classic mistakes with functions. And so here is an example function up top. And I've got the proper heading, so it starts with lowercase function, some output. The name of the function is what am I doing wrong, and it has 2 inputs, input 1 and input 2. The very next line of this code is input 1 equals 1 by 1 to 10, input 2 equals 10 minus 1 to 1. And then I compute output as input 1 dot times input 2. And then I end my function. And of course, so let me give you an example of what would happen if I ran this function. So to call this function, I'm going to copy and paste the function, and input 1, let's make an error. I can put 2 or 3 times 2, and so I'd expect this to multiply 3 times 2 and give me an output of 6, right? So let's run that, oh, that's weird. It gives me a 1 by 7. So what is going on here? Actually, sorry, A and S is a 1 by 10. So if you want to check that, you can look over there in the workspace. That's weird. Well, let me try to put a different input. Let's say, well, let me do an array this time. So let me do a array, and I'll do 1, 2, 3. So it's a 1 by 3, and I better pass it, since I'm dot multiplying, I could just pass it 2, and it'll multiply, should multiply 2 by every input of this array. So I'll try that again. Oh, I'm getting the same problem. And actually, so one thing is I didn't suppress a function output. I could, let's save that. So go ahead and I'll run that again, and it'll just give me A and S. But regardless, I could put in anything. I could put not a number. So N, A, N, and N, A, N. And it seems regardless of what I put in, it's not changing the output. And that's not how we want our functions to work. Remember, we want our functions to change based on our given. So of these choices here, what has caused it to go wrong? And you can pause the video if you want and think about it. Okay, so the answer is that the inputs have been overwritten in the function. And how did I overwrite them? Well, the very first line of code, no matter what input is, say the first example, it was 3, but I overwrote it and changed it to this 1 by 10 array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the same thing, I am changing input 2 in my second line of code. So I see this happen all the time, is that people overwrite their inputs, and what that does is it gives you a function that's not very useful. Regardless of your inputs, it's always going to give you this overwrite your inputs and give you the same output. So be very careful. Never, ever actually redefine an input from a function. You can do manipulations based on that, but never redefine a function input. So next I want to talk about subfunctions. So for example, say I have a function here, and the name of this function is myAge. And what it takes is an input, the year you were born, and then whatever year it is today, and it returns your age as a dog and your age as a human. And if you look here, the computation for age in a human is quite simple. It's just the year today minus the year you were born. And of course, you can make this more sophisticated if you want to include months, but this is just for argument's sake. And then it also has the age as a dog. And it assigns that to, dog years. Well, is that a function in MATLAB? No, it's not actually. I'm making a subfunction that's within this function. And the interesting thing about subfunctions is I could not call that subfunction anywhere in my command window or in another script. So it's only accessible to this function, and that's quite convenient because I don't have to save a new M file called dog years if I really think I'm only ever going to use it in this myAge function. So this function does not exist in as a standalone script. Now the standalone function script is saved under myAge, so that's right here. Okay, so if I want to run this, of course, what I could do is I take my age and just say the year you were born. Let's just say you were born in 1990, and today is 2018. And then I'm going to run this. And of course, I couldn't go ahead and run it over here in this script editor because that's not a valid way to run a function. Remember, I got to call a function. So I need to write the function and then pass it the correct number of inputs. So if I only did one input, I need 2 arguments, so it's going to crash. So let's go ahead and change that to 2018 and compute it. Okay, and so it's returned 196. And why did it return 196? Because it ran age as dog. That was its first return, and it ran this subfunction dog years, and I passed it my age as a human, which I computed up here. And of course, to do that, you just multiply your age times 7. Now, why did I not get my age as a human? Well, because I didn't request that. So if I want both my age as a dog and my age as a human, I need to request that. And of course, to do that, you need to give it a bracket. So the proper way is, this is the I am assigning to these variables whatever output comes from the function my age when I pass it 1990 and 2018. Okay, and so your age as a dog is 196, and your age as a human would be 28. Now, just to prove this point a little bit further, is can I actually access this dog years function? And let's just say 28. We know that if it's 28, you multiply that 7, it's 196, and that's an undefined function. That's because this is a subfunction of my age. So those are very useful. A common good practice when writing functions is to comment your function and include that as a header. So the first set of comments following the function name are going to be really very helpful for you as the author, but it's also helpful for your readers. And so what you should, good practice, to include is a description of the inputs, also the type. So this inputs, I'm telling the user F, the input F is a temperature in Fahrenheit, so the units, and it's a type double. I'm telling them that the max temp should be the maximum temperature that the user wants, and a double, and then the output should be C, and the output is going to be in Celsius, that's a double, and Kelvin, K, and then a flag that the max temp was exceeded. That class is going to be a logical, and I also have the author sort of a version. So this is my first draft of it, and the date when I saved this. Of course, this is where you're going to have to write your code here for Lab 2. And why this is really useful is we can go to the command window and type help and whatever function, and what it would pull up for us is actually that whole first set of comments. Now, it didn't pull up the add code because even though that's a comment, because there is a space in between there. So for example, I wanted a space for my reader in between the sort of function description and the inputs, and maybe I should even do one for the outputs. If I go here and put a space there, let me save that, and I try to do the help again, you see that it only went to the outputs, and that's because once it's the next set, once it's after this space, it will not display that to the screen when you type the help command. So if I want that space, I better put a comment there. One way, just in general, to comment out large sections of code or uncomment, you can right click after highlighting it and say comment, or you can uncomment. So those were already commented, so I can uncomment. So that is a very useful thing. So let me save that, and then I'll show you help again. So this is very useful for your users of the function. That way they don't have to go open up the function, digging through it, and try to figure out what you intended this function to do. And so for all of your homework from here on out, really all of your functions should include, at a minimum, the inputs and outputs, but should also include a short description of the purpose of the function, as well as your name as the author of the function. Okay, so a common scenario when writing functions is we might want to know how many inputs the user has given us, because remember before, if we didn't give the right amount of inputs, we had our file or the function run just crash. But maybe we don't want that to be the case. So I've wrote a function here called addMe. It takes two inputs, A and B, and I'll talk about what the heck this switch and case stuff all means. This is a form of branching that I'll cover in the next lecture video. But what it does is we'd like to, based on the number of inputs, do a different calculation. So if we were given 2, we're going to add A and B, those inputs. If we're only given 1 input, then we're just going to add that input with itself. And if we're not given any inputs, so that's the other case would be that there are no inputs, we're just going to say C, the output here is 0. Now, I didn't have to put it in brackets because there's only one output. You can if you'd like, but it doesn't make a difference. And the first line might catch your eye here. I says number of inputs equals nargin, but you're saying, Jose, I don't see that variable as an input, and it doesn't look like a variable over here in the workspace anyways. When I run this function doesn't have an access to the workspace. So what is nargin? It turns out nargin is actually short for number of arguments, and it's a local function in MATLAB. So if you do help nargin, it's actually a function, and when it's given in context of a function, what it will return is the number of arguments the user has passed to the function call. To see this in sort of work, let's go ahead and set a breakpoint right before the switch case, actually. So I'm going to set a breakpoint, and I better save that here. And so what I can do is addMe, and let's just pass in 2, 3. And we run that. And you'll see here now in my workspace, this is the sort of local variables that are created. Now these are only temporary. This isn't my real workspace. This is just the local workspace for this function while it's executing. As soon as it's done executing, these variables will be deleted. So it took the 2, assigned it to A. It took the 3, assigned it to B. And then it counted, nargin returned 2 and assigned that to this variable number of inputs. Okay, and when I put continue, it goes ahead and executes the rest of the code, and we can see what it ran was case 2, where the answer was 5. Now, if I redid this and just did, let's say, addMe, it's going to go in here, and the number of inputs is 0 because I didn't give it any inputs. But that's not a problem. Remember earlier on in this lecture, this caused a function to crash. Well, we have a way we can catch that, and we're still returning the variable C. So what would cause the error actually is when I try to return C, and that's not in the sort of local workspace of this function. But now, regardless of the inputs, we're going to make a variable C so it won't crash. Okay, so the answer is 0. And then let's do the third case, addMe. Let's just do 5. And of course, this should, so I'm pausing it right here. This green arrow lets you know that that's where it's executing. And now we have number of inputs equal to 1. So let's continue executing the code, and we got that the answer is 10. So that's how nargin can be very useful for you as a programmer if you don't know how many inputs your user has passed, but you want to do multiple things based on the number that they pass you. Just like nargin, we can also tell the number of arguments out that the user has requested when they call a function, and that's by using narg out. So what this code is going to do is I have this function subtract. It takes 2 inputs, x and y, and it computes the difference. And if the number of outputs, which is given by narg out requested, is only 1, it's just going to compute the difference. And it doesn't need to take the absolute difference because that isn't calculated. So when we don't calculate that, it's not going to throw an error. And the other thing here is it'll display, let you know, hey, I'm calculating this absolute value. Okay, so let's try this over here. So let's say subtract, and let's just do 3 and 4. And of course, when I did this function call, I didn't even assign it to any variables. I didn't say like variable a equals subtract 3 comma 4. So now we're here in the debugger, and what I've done is I've paused it after number of outputs, and what nargin read was that there were only no outputs requested. The default, of course, is just to assign the very first one to this function call. So what I'll get here is ANS is equal to y minus x, so I should get -1. So I'll continue running that, and ANS will equal -1. Okay, but if I wanted to see the difference between y and x, and also the absolute difference, what I can do is request both of those. So I could say to request 2 outputs, I have to do it in an array form, and the first variable, let's call it the difference, and the next variable, we'll call it the abs difference. And then we're going to assign that with the equal sign, whatever the output of the subtract function call is. So now the number of arguments that I'm asking for is 2. So let me go ahead and run this, and you can see now that the number of arguments returned by the function nargout is 2. And now I'm stuck with this choice here. It says if the number of outputs is greater than 1, in this case that is true, then what it should do is display this text and then calculate the absolute difference using this abs function and return that for our user. And we in fact see that. So here is the display to my work or command window, and then I was also given the difference and the absolute difference. And the final function input that I'm going to tell you about is the 2 functions that we can use are called vargin and vargout. And what that does is, say I don't know how many variables in I want to have this function have, and I don't know how many variables out my user may request. And what I can do is actually just leave that undefined, and then my program can make an assessment based on the variables that the user puts in and the variables the user puts out. So in this case, I'm going to display the following text. So I'm concatenating the string that is number of provided inputs. So that's this string, and I'm concatenating it with this function here. We'll take the length of vargin, so whatever the length of my variable input is in, and then convert that into a string. So for example, let me just show you what num to string does, so you know what I mean. So num to string of, let's say, 5 actually is not 5 a double in ANS. Over here you'll see that it's a car. So the class here for ANS is a 1x1 car. What I'll do as an example is go ahead and use the following line of code. So in this in the brackets, what I'm doing is saying I'd like to receive 2 outputs, and I'm going to call that with my function, and what I'm passing it is 1, 2, 3, and this is actually not 4, 5, 6 inputs. This is actually just my 4th input. And so my input is actually an array. You can pass, you don't just have to pass one value. You can pass arrays. You can pass cells. You can pass all kinds of inputs. So this was actually 1, 2, 3, 4 inputs. And remember, our inputs are always separated by commas. So these spaces here are not seen as inputs. So I'm going to run this, and the display here is that the number of provided inputs is 4, the number of requested outputs was 2, and then it went ahead and counted A and it counted B.